Solve for equation of perpendicular linear function. Solve for the equation of the perpendicular linear function of the segment passing through the points on the coordinate plane whose coordinates are 1, 4 and -2, 3. So we are basically trying to solve for the equation that is perpendicular to the linear function if passing through the points of the coordinate plane, and it is 1, 4 and -2, 3. And if you think about this segment, which means a straight line on the coordinate plane, we can always think about it as the linear function that satisfies its own equation on the coordinate plane. So this question will be related to a linear function, but especially through the equations, which means some kind of specific form of the linear function. So there are 3 things in order to solve or approach this question. And the first thing will be the types definition as well as the forms of our linear function, because the linear function will be the most important thing when it comes to solving this question. Linear function is also a types of function that we notate on our coordinate plane, and usually we notate function as y or f of x because there are no terms to express our function. So y or f of x are usual terms that we express our functions on the coordinate plane. And if you think about exactly what the function's type will be, the function is a stuff. So there will be a function, but that function will be something that requires a specific input. So the function system requires a specific input to that function, and since we input a specific values, they will generate a specific output of our linear function. So usually when it comes to solving the function problem in the easy part of the systems of function, we usually think about the function as 2 parts. And then first part of our function system in the easy part will be our quadratic function. The first function will be a quadratic function system. And if you think about what this is, its standard form, which means the basic format that we usually notate in order to express the quadratic function will be y is equal to ax squared plus bx plus c. This is a standard form of our quadratic function. And if you convert our quadratic function on the coordinate plane, it will gonna generate a specific parabola that satisfies its own equation that it has. And the second thing that we're going to talk about, which in this case will be a linear function on the easy system of the SAT question. So this second thing will be our linear function. And the linear function is exactly the same kind of concept with the quadratic function, except the quadratic function has the higher power term in the x terms. The basic format of our linear function will be y is equal to mx plus n. And if we convert our linear function into a specific graph on our coordinate plane, unlike the quadratic function, it will be a straight line or segment that satisfies its own equation, y is equal to mx plus n. We're trying to think about this question through our linear function, which is y is equal to mx plus n through this question. So this question is basically about our linear function systems. So our linear function y is equal to mx plus n. We know that y is equal to mx plus n will be our standard form of our linear function. And if you don't know the definition of the standard form means it is a most basic format of our linear function or any other function. In this case, it will be y is equal to mx plus n. And we know that our linear function is y is equal to mx plus n when we need to think about what does its variables or constants defines in our function. So the first thing that we should talk about or think about will be our y, or we also notate it as the f of x. And y or f of x, as we have talked about this, it will be some specific output. It will be a specific output of our function. And the second thing that we need to talk about is x. The x value, as we can see, this will be our specific input. This will gonna be our specific input of the linear function in this case. And the reason why I always think about y or x is because this is a thing that actually defines our function. The reason is because we know that y we usually notate it as the f, and we notate our x value with just x. And since we added these two elements together, we'll be able to get our f of x, and the f of x will be our function. That's why the x and y value is the most important thing that generates this specific function. And the third thing that we need to talk about, in this case will be the coefficient of the x value, which is m. The m value will be a specific slope, which shows how steep the line or the linear function lies on our coordinate plane. And the way to solve it, the formula for solving the m will be changing x over changing y, which means we're trying to solve for how the x and the y value changes or defines on our coordinate plane. And if you think about this specifically, you will be x2 minus x1 over y2 minus y1. The reason why we're thinking about x2, x1, y2, and y1 is because in order to think about the change in x and the change in y, we always need to think about it through the 2 points. And if people can think about this, where are 2 points? The first point, which we're gonna notate it as the a value, will be x1, comma y1. And the second point will be b, which we will notate as the x2, comma y2. From these 2 points, or we call it as the coordinates, from these coordinates we'll be able to solve the slope, which we notated as the m value in this case, in our linear function, how steep the function is. And if you show how steep the function is through our graph of our linear function, in order to draw a graph, we always need or require a specific coordinate, which means we need to have a special coordinate plane in order to express how steep the function is. So obviously on the coordinate plane, there will be a specific x and the y value, x and the y-axis, so the x and the y-axis. So which we noted as the horizontal and the vertical axis. Let's say that the line or the linear function goes something like this, and this is just an example. So we're just gonna notate this as y is equal to mx plus n. So our n value, in order to see how steep the function is, we always need to think about this in this way. We know that the x value is the input value, and our y value is always the output. And in order to think about the slope, how steep the function is, we always need to have the 2 coordinates. So let's say one point is right over here, we're just gonna call it as the a value. Let's say another point is right over here, which we're gonna call it as the b point. In order to see how steep the function is, we need to think about the difference. So we usually think about this through a triangle. That's why in the change in x, we use our triangle signs. So from here, let's say that our point B is x1, y1. And let's say that point A is x2, y2. From here, we always need to think about it in this way. So from this, we're thinking about how the difference between the points will exist. So this one, as we can see, it is on the x-axis, so we'll be changing x over. This will be an y-axis, so it will be changing y. This will be changing x and then changing y, which shows our slope, how steep the function is, our m value in our linear function. This is how the slope will be defined in our linear function. And lastly, let's think about what is the n value. There are two types of lines that the question makers will give you in the linear function systems questions. The first thing that they want to give us is if you know what the parallel lines will be. And if you think about what the parallel lines, that means if you draw it, it will look something like this. That is parallel, and if you want to know why it is parallel, we can make a straight line between them and see if they are the right angle exist. And since we knew that these lines are parallel, and we also talked about this through 2 videos in the last, and if the parallel lines exist, we always need to think about, even though it's perpendicular or not, we always need to think about it through the first thing will be our slope, and the second thing will be our y-intercept. Slope and the y-intercept will be a thing that defines perpendicular or the parallel lines. The slope of the parallel lines, should be exactly same, so it should be equal. But then the only thing that makes them different will be the y-intercept. The y-intercept should be different in order to create a parallel lines. This is what the types of lines in the parallel lines will be. So the slope should be exactly same but has the different y-intercept in order to create a parallel lines together. So let's think about the second thing, and the second thing will be if you know what is a perpendicular line. So the second thing will be if you know the perpendicular line. And if you think about perpendicular lines in 3D graphs like the parallel, let's say there is a line that looks something like this, and the perpendicular will look something like this. And if you want to know if it's a perpendicular, you should create a 290 angles, and another way 180 degrees, 90 degrees, and here 90 degrees. This is what the thing that we can prove if it's a perpendicular line or not. And if you know the perpendicular line as we did through these parallel lines, we always need to define them through the slope and the y-intercept. For the perpendicular line, it's a little bit different with our parallel line because the slope, according to its property, the slope should be minus plus reciprocal. And some people might not know what is the reciprocal. So if you write it down again, the slope should be minus plus the reciprocal. Let's say, in order to define what I mean by reciprocal, let's say there is a fraction called y over x. The reciprocal will be x over y, which means we are changing the direction of the denominator and denominator. This is what the reciprocal is. But then we are adding the minus to it in order to solve for the slope of the perpendicular lines. The second thing will be our y-intercept. In the perpendicular line, the y-intercept should be exactly same, which means it should be equivalent. The reason is because the y-intercept will be a specific point that is a intersection. So the y-intercept will be the intersecting point between our two graphs. This is what these perpendicular lines will going to be, unlike the parallel lines. This will be a two cases where the question maker will gonna give you in the SAT linear function systems. If you don't know exactly what the perpendicular line will going to be, we can make an example for it. Let's say the original line will be y is equal to mx plus n. According to the property, the perpendicular line will be exactly the same, except y is equal to reciprocal, which means plus minus plus 1 over m. The position between the denominator and denominator change, and with the same y-intercept. And this is the changed perpendicular lines equation we're going to be. And if you go back to our original question, we're also trying to solve for the equation, which means the form of a perpendicular line. So let's actually get through our equations. So we need to solve for our actual linear function in order to solve for our perpendicular line. But they didn't give us what the function was going to be. All they gave us is the coordinates, and our coordinate will be 1, 4 and negative 2, 3. They didn't give us how to solve the original equation, but the only reason why they gave us the coordinates is because we know that our any function can be summed up as the y is equal to mx plus n in the linear function. And the only reason why they gave us two coordinates is because they're telling us to solve for the slope of our linear function. That's why it's a little bit advanced one. And in order to find the slope, all you have to do is we apply our change in x over change in y to solve for the slope. And then we're trying to solve for our y-intercept. How can I solve the y-intercept? Since we solved our m value, our slope, all you have to do is input one of our coordinates back to our original function, isolate our n value, and solve for our y-intercept. And then we convert our function into a perpendicular line, into a perpendicular linear function. Then they're going to give us the answer for our question. Let's write our coordinates down again. Our coordinate, let's make it as the a. The coordinate a will be 1, 4. Coordinate b will be negative 2, 3. These are the coordinates that are given. And through this, obviously, we can solve for our m value, which will going to be our slope, how steep the function is in our linear function system. And so let's apply our x2 minus x1 over y2 minus y1. And as we can see, the order won't be a matter. And if we just say that this one is the x2 and the y1, y2, this is an x1 and the y1, we can go in this way. 3 minus 4 over y2 minus y1, negative 2 minus negative 1. But then, so this whole thing will be negative 1 over negative 3. And this can be summed up as 1 over 3. So this will be 1 over 3. So let's raise them for our spaces. So our m value will be 1 over 3. So from here, we can write our full, not a full, but y is equal to mx plus b. But instead of m, we apply our 1 over 3. So y is equal to 1 over 3 x plus b. So we need to solve for our b value, which will be our y-intercept. we need to solve for our b value, which will going to be our y-intercept. And as we have talked about our strategy for this part, all you have to do is apply one of our coordinates. We need to apply one of our coordinates to our original function. And if we apply our function at the coordinates, we will be isolated. We can isolate our y-intercept, which is b, and solve for it. So let's apply a value because it looks so simple. So if you apply our point A, which is 1,4, to our y is equal to 1/3 x plus b, we can go in this way. Our y value in this case will be 4, our x value will be 1. So will be 4 is equal to 1/3 x plus b. And if you don't know what the x value would be, the x value we are inputting as 1. 1/3 times 1 will just be 1. So our full function will be 4 is equal to 1/3 plus 1. And in order to solve for our 1 is b, in order to solve for a b value, and if you don't know what the b value is, it is a y-intercept. In order to solve it, all you have to do is subtract 1/3 to the both sides. So it will be 4 minus 1/3 is equal to b. And if we complete our calculation, 4 minus 1/3 will be 3, and then 3 in the denominator, and then 2 in the numerator. So this will be what the b value will be. And b value was our y-intercept. So we can make our full function. Our full function was y is equal to mx plus b. And we can replace our m value as 1/3 and b value as 2/3 as we have solved it. So it will be y is equal to 1/3 x plus 3 and then 3 in the denominator, 2 in the numerator. This is what the full function will going to be. But we are not done yet. We just solved our original. It was our original function. And we're trying to solve for our perpendicular line. We're trying to solve the perpendicular function that is perpendicular with the linear function y is equal to 1/3 x plus 3 and 2/3. But according to its property, we always need to define this through our slope and our y-intercept. And according to its property, as we have thought about it, our x-intercept, so our slope should be negative plus reciprocal, which means changing the position between the numerator and denominator. Our y-intercept will be exactly equivalent in order to solve for our perpendicular line. So in order to solve for it, all you have to do is write our full function down again. Our full function was y is equal to 1/3 x plus 3 2/3. And our new function will be y is equal to the y-intercept will be exactly the same, 3 and 2/3, but the only thing that is different will be our slope, how steep the function is. And our original slope was 1/3. If you want to solve for the slope of the perpendicular line, all you have to do is add negative and the reciprocal. Firstly, let's think about the reciprocal first. If you're in reciprocal, 1/3, it will just gonna be 3. But we still need to add our negative value, so it will be -3. -3 will be our slope of our perpendicular line. So all you have to do is add -3. So y is equal to -3 x plus 3 and 2/3 will be our answer for the perpendicular line. That is perpendicular with our original function y is equal to 1 over 3x plus 3 and 2 over 3.